Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 2, Lesson 8, Session 1, adding with negative numbers. So, learning target includes adding positive and negative integers, fractions, and decimals. Show addition with negative numbers on a number line. Use zero pairs to help with negative numbers. So here we go. Always, sometimes, never. A. The result of adding a positive number and a negative number is negative. Okay, so let's see. 3 plus a negative 2 equals 1. Okay, that's not negative. So always, so I'm going to put A, S, N underneath here, and I'll cross out the ones that I disproved. So I'd have a positive number and a negative number. It did not result in a negative, so always is gone. It's either sometimes or never. But if I use that same 3 and then I add a negative 4, 3 plus negative 4 is negative 1. So it's not never because I just gave you an example of one, so this must be sometimes. Okay, there's the first one. Next one. The result of adding 2 or more negative numbers is negative. Well, I'm going to use a number line to explain this. It's just quicker and easier. Here's a number line. Here's 0. So if I start with negative 1 and I add a negative 3 to it, okay, it would look like this. Start at 0, go to negative 1, start at negative 1, go to 4, negative 4. So this is negative 1, and this is negative 3, totaling negative 4. The result of adding 2 or more negative numbers is negative. All right, well, if you're adding 2 negative numbers, you're going left, then you're going further left, so you're getting further from 0. There's no way we can get back to being above 0, so this is always. There's no way we can get above 0. C, the result of adding 2 or more positive numbers is negative. The result of adding 2 or more positive numbers is negative. So here's 0. Here's 2. Okay. If I take this and I start at 0 like we always do, and I drag it out to 2, there's my first number 2. The result of adding 2 or more positive numbers. So there's 2. But if I add another positive number to it, we're going to start at 2, and we're going to go to the right, and this might be 1. Actually, I switched to black. This might be 1, 2, 3 long. So 2 positive numbers, 2 plus 3, will never be negative because we're going to the right of 0 and further to the right of 0. So this is never. Weather stations provide information about the weather. A home weather station may provide basic information such as temperature and humidity. When have you needed information about the weather? So let's try it. The temperature at a mountain weather station is -3 degrees Fahrenheit at sunrise. Then the temperature rises 5 degrees Fahrenheit. What is the new temperature? So what I'm going to do here is I'm going to draw a vertical number line. I prefer vertical over horizontal when we're talking temperature changes because it's, you know, temperature rises and falls. It doesn't go left and right. So here's a number line. So we're starting at, here's 0, here's -1, here's -2, and here's -3. We're going to start at -3. But how did we get there? Well, if we start at 0, it means we went down 3. Okay, we're 3 below 0 Fahrenheit at sunrise. The temperature rises 5 degrees. So there's 3 degrees plus 2 more is 5. I just gave you the answer. -3 rising 5 degrees would get us up to +2 degrees on the thermometer. Okay. Already did all this. Let's just skip those. Look ahead. To find the new temperature, you found the sum of a positive and negative integer. You can use a number line to help you think about adding positive and negative numbers. During the day, the temperature at another weather station is 4 degrees Celsius. So we go from 0 up to 4. Overnight, it changed by -9 degrees. It dropped 9 degrees. So dropping 4 would get us back to 0, and 5 more will get us to -5. Hasina says she can model it with 1 arrow. How can she model this situation with just 1 arrow? Okay. I guess what you could do is just not write the first arrow that tells us to go to the right 4. Okay. So if I do this, perhaps that's what they mean. Start at the temperature we're at, 4, and go left 9. Okay. So what is the sum of 4 and -9? Well, 4 plus -9 equals, if I take the absolute value of 4, it is 4. If I take the absolute value of 9, it is 9. Take 9, subtract 4, I get 5. All right? That meant to be -9. You take the sign of the larger absolute value, which is -9. So the answer is -5. How much would the temperature need to change the next day to be 0 degrees Celsius? So in other words, -5 plus some number has to equal 0, right? So if I add 5 to get rid of this, now that's a 0 pair, and I add 5 to this side, this is a 0 pair, it's gone. I get x by itself, 0 plus 5 is 5. It would have to change, increase 5 degrees to get back to 0. Okay, reflect. What addition expression does this number line model below? Okay, so notice where the dot is. They just didn't show this arrow here. So that would be starting at 3, and we're adding 1, 2, 3, 4, 5, 6, 7. We're adding a -7 to it to get -4. So it's 3 plus a -7 equals -4. Okay, so that brings us to the end of session 1. Hi there, Mr. Holcomb here with another lesson in geometry. This is Unit 2, Lesson 8, Session 2. Okay, so the objectives are the same as Session 1, so I'm just going to continue. And connect to context, it says each liquid has a freezing point or temperature below which it becomes solid. The phrase below freezing is based on the freezing point for pure water, or the temperature at which it might snow. So if we're talking about Fahrenheit, that is 32 degrees Fahrenheit. If we are talking about the Celsius scale, that is 0 degrees Celsius. They're equal in temperature, but different on their scale. All right. So normally the freezing point for water is 32 degrees Fahrenheit, as I just stated. A city treats its streets before a snowstorm. On the treated streets, the freezing point for water is changed by -38 degrees Fahrenheit. So what they're talking about here is when there is inclement weather in the forecast, that is calling for precipitation and temperatures below 32 degrees, okay, they will send plow trucks out with tanks on them. And in those tanks is this mixture of water and salt, basically. They're a saline solution that they spray on the roads. And salt lowers the freezing temperature so that water will not freeze at 32 because it's going to hit the salt, saline, slurry, whatever you want to call it. And it's going to be like, okay, it's 31 degrees, but I'm mixing with salt, so I'm not going to freeze. It doesn't freeze until it gets lower. So the salt keeps it from freezing at 32 and doesn't allow it to freeze until it gets much colder. Okay, this temperature that they gave us is not true. It does not lower it that much. Usually it's 15, 17 degrees and that's it. But we'll go with this problem because those are the numbers they gave us. So let's start with the freezing point and 0. So here is 0 degrees Fahrenheit. I'll put 32 degrees Fahrenheit up here. Okay, so it says normally the freezing point for water is 32 degrees Fahrenheit. So that's where it's going to freeze. A city treats its streets before a storm. On the treated streets, the freezing point of the water is changed by 38 degrees Fahrenheit. So what this problem is going to ask us is, what temperature will the roads freeze? So what we're going to do is we're going to lower our freezing point. So one way to do it is to focus on our distance from 0, which is the absolute value. So if I go from 32 down to 0, that is a decrease of 32 degrees. We aren't at our 38 degrees yet. We also will need to decrease again by how many more degrees? 33, 34, 35, 36. Okay, so that would be another. So this is negative 32 degrees. And then this is 33, 34, 35, 36. Okay, 37, 38. So 1, 2, 3, 4, 5, 6. All right. I will go over that one more time. Just trying to get my arrow correct. Okay, that's about right there. So this is down 32 degrees, 33, 34, 35, 36, 37, 38 would be here. So this whole distance is a distance of 38. We've already gone 32. We need to go 6 more. So the water on the roads will freeze at 6 below 0 instead of at 32. Okay, that's kind of a stretch, if you will. It's not that much. It might only be like 15 to 17 degrees, but no more. But in this problem, they're saying 32 minus moving from 32 to negative 38 or decreasing that 32 degrees by 38 degrees gets us to 6 below 0. Okay, so you can use the number line to find the sum. I did a vertical. So what they did was they started with a point at our 32 degrees, the freezing point. We dropped 32 to get to 0, and then we dropped 6 more to get to our answer, which is negative 36 degrees. Okay, just a quick model it. And then we can also represent the situation with an addition expression. So 32 plus a negative 38. And let me explain what they're doing here. They're creating 0 pairs. So you're focusing on this 32. So there's a 38 is more than 32. So let's write negative 32 here. And how much more do I have to add to that to get to that 38 that we had? Well, it's negative 6. So they're representing negative 38 as negative 32 plus a negative 6, which is true. Okay, these are still both equal. But then what happens is we have 32 degrees and a negative 32 degrees that offset each other. They're called 0 pairs, and that which means they add up to 0. And then so that's 0 plus a negative 6. So to finish this off, we would have this, and then obviously anything added to 0 is itself because 0 is the additive identity, and we get the answer to be negative 6 degrees Fahrenheit. Okay, whoops. Clearing from page, that was from my last class. Okay, so a dragonfish is swimming at negative 900 meters relative to sea level. So the first thing I'm going to do, excuse me, is put 0 right here. That is the top of the water. That's the surface of the water. This is air. This is underwater. Okay. A dragonfish is swimming. So let's get our arrows. Let's make them red. It is going to dive down. It is going to dive down 900 meters. That's pretty far. So right here, we're at negative 900 meters. Okay, I'll just put a little m there. So we're talking about meters. Oh, by the way, I am writing behind my back. So let me move this. Let me move all of this over. I'm going to do this over here. Okay, sorry about that. Forget that my head is in the way. So here is our number line. Here is 0 degrees. Here is negative 900 meters. So that is the depth of the fish, okay? The dragonfish. It rises 250 meters. So then what I'm going to do is draw another arrow. I'll make this one blue because it's going up. And I'm going to go up, oh, I don't know, maybe this much. And I'll write the numbers next to it, what this means. So this is negative 900, and this is a positive 250. So where did we end up? That's what the question is. So what is the dragonfish's new depth relative to sea level? Show your work. Well, it's basically negative 900 plus 250. Okay. So what we do here is we're going to take the absolute value of negative 900, which is 900 because absolute value means distance from 0. How far is 900 from 0? It's 900. We're going to take the absolute value of 250, which is also 250, and we're going to subtract. So 0 minus 0 is 0. I have to borrow and 10 from my 9. Okay, so bring that 8, bring this over to 10. 10 minus 5 is 5, and 8 minus 2 is 6. So this is negative 650. Okay, but I got 650. Well, I did the absolute value, but the rule states that once you're done, you take the sign of the bigger number, which was negative, so your answer will also be negative. So negative 900 degrees, or 900 meters, swimming up 250 meters up from where it was would put it at 650 meters below sea level. Oops, didn't erase any of these. See edit. Sorry about this. Clearing from page. So now it's saying, what is 79 plus a negative 26? So let me go back to three slides. Where did it go? Maybe I went too many. Right here. So we're looking for two numbers that will add up to a given. Let's see if we can do that in this problem here. Okay, well, 79 and negative 26. So what can I represent 79 by? I could put minus 26 in here and put plus a negative 26 out here like it is. Okay, well, and if I do it this way, though, we are actually going to get the answer by trying to figure out. So I would prefer not to do it that way. But if I take the absolute value of 79, it is 79. If I take the absolute value of negative 26, that is 26. The signs are different. Say that's plus a minus means subtract, or a negative, plus a negative means minus. So we're going to subtract. 9 minus 6 is 3. 7 minus 2 is 5. The sign of the bigger was positive. Our answer is 53. Okay, and then finally the exit ticket. I will do this in the video. All right, so add negative 18 to negative 67. So in this situation, we have two negative numbers, negative 18, and we're adding a negative 67 to it. In this case, we're going to take the absolute value of negative 18. That means, well, how far is it negative 18 from 0? Well, it's 18, so that's positive. Okay, distance is always positive. And what is the absolute value of negative 67? Well, negative 67 is 67 units from 0, so the absolute value is 67. Since the signs are the same and we are adding, I'm just going to simply add their absolute values. 8 plus 7 is 15, carry the 1. 6 plus 1 is 7, plus 1 is 8. I get 85. So I'm going to write 85 here. However, when the two signs are the same, we take the sign of them. So my answer is negative 85. Okay, so in other words, what are we doing? When you have two negatives and you're adding them, you add their absolute values, keep the sign. And that is the end of session 2. Okay, welcome to another lesson in pre-algebra. This is Unit 2, Lesson 8, Session 3. And we're still doing adding positive and negative integers, fractions and decimals, and using zero, pairs, and number lines. So here we go. The word scuba is an acronym for self-contained underwater breathing apparatus. Although modern scuba equipment was invented in 1943, underwater diving dates back to ancient Greece. Okay, so we're going to talk about a scuba diver here. So it says on a cave dive in Oahu, Hawaii. Okay, I already made my arrows for you here. Let me just move them off the. Okay, in Oahu, a scuba diver swims at an elevation of negative 20 3/4 feet relative to sea levels, which mean that I'm going to draw this here. I'm going to make this my 0 because that is sea level, and that negative 20 3/4 is feet. Okay. Hopefully that's not behind my head. Let me move it just in case it is. So how about I move it to right about, oh, I don't know, how about over here? It'll fit over here. Let's do that. All right, so here is our number line starting at 0, going down to the depths of, this distance here is negative 20 3/4. Okay, so therefore that's where the diver is located. All right. The scuba diver then notices a sea turtle above. It's called a honu and rises 6 feet to take its picture. So we're going to take this arrow and start it at where we were at the depth of 20 3/4 feet. And we're going to move it up so that it is at a length of a positive 6 feet. Questions one asking. So here we are right here. It hasn't asked yet, but it will ask, where did they take the picture from? Okay. So that's what the question's about. So I drew the model with a number line, dove down 20 3/4 feet, swam up 6 feet to take its picture. Where did he take his picture? Where did he take the turtle's picture? All right. So we can break apart the mixed number. So I had them practicing this in class. Please, 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 if students are watching this again, or if you are absent, please follow these steps. Please do not just type this in your calculator and get an answer. We're not so much concerned about finding the right answer as we are learning a procedure and grouping and knowing what an integer is and what a rational number is. So please just do it in this fashion. So we have what is called an integer, which are positive and negative numbers, including 0, that are not fractions or decimals. By definition, an integer is all whole numbers and their opposites. Okay? So that is an integer. This is the integer part of that, this right here. Okay, so negative 20 is an integer, but negative 20 3/4 is a rational number because it's not a whole number or a negative of a whole number. Okay? Hopefully that makes sense to you. So then we're going to highlight the rational portion. So this is, we can split up a mixed number to a whole number or an integer and its fraction component, which would be an integer and a rational number. So the green is an integer and the blue I'm highlighting is the rational portion. So negative 20 3/4. A lot of students get confused with this. So I'm going to draw a number line to explain this. If we're on a number line, okay, and we are at 0, negative 20 3/4, let's just say this is, let's just draw negative 20 here. This distance right here is a distance of negative 20. Okay, actually, I'm going the wrong way. Let me put the 0 over here. Let me do it correctly. Sorry about that. 0 is here. Let's say negative 20 is here. So then when I draw a line segment in red from 0 to negative 20, well, how far is that? Well, it's a distance of negative 20, or it's left 20. Well, this says 20, negative 20 and 3/4. So the 3/4 is also negative. So we need to draw another number line, or a line on the number that is a much shorter distance. And that distance there is negative 3/4. So the total would be negative 20 and 3/4. So, excuse me, the integer is negative 20, and the portion that we're adding to that is another negative 3/4. So negative 20 and 3/4 is a negative 20 plus a negative 3/4. A lot of students get confused thinking it's negative 20 plus 3/4. Well, it's not plus 3/4, because if it was plus 3/4, this is what we would have. And I'm trying to be very specific here so we avoid this error. So if that arrow is a distance of positive 3/4, and you thought this was positive here, then we're really only at 19 1/4. Okay? Well, that's not 19 1/4. It's negative 20 and negative 3/4. Okay? All right, let me go back to, what was I doing? My highlighter. Actually, I could just do this. Let me drag this down here. So there's our two parts. All right, so let me now just get rid of this. Trying to just choose these and get rid of them. Okay, let me just move this out of the way and get rid of this. Sorry for the delay here. And then I'll put this back. Let me just move this a little bit more. There we go. That's how it was lined up. Okay, so we have a negative 20 and a negative 3/4 plus 6. So that's all we did in this first step, was separate the rational from the integer. The next step is just flip-flopping, rearranging our order here, and that is called the commutative property. Commutative property of addition. Okay, so all we did was negative 20 stayed where it was, 6 switched places with the negative 3/4. It's still going to equal the same thing. And then what they did was they focused on the integers. Now we can combine the integers. So negative 20 plus 6 is negative 14. And then we add another negative 3/4. So the answer is negative 14 and 3/4. Okay, so this is how we're going to be doing the rest of this lesson. So now I'm going to go on to the next problem. And it says a chemist has a mixture with a temperature of 3.5 degrees Celsius. Then they cool the mixture. The temperature changes by, so we're going to add a negative 14.2 degrees Celsius. What is the temperature of the mixture after it is cooled? So we're just going to follow that previous procedure, and we're going to split the decimals away from the ones, or the whole numbers, the integers. So the integer of 3.5, the integer portion is 3, and then I'm going to add 0.5. 3 plus 0.5 is 3.5. So we split those up, and then we say plus parentheses negative 14 plus a negative 0.2. Okay, so all we're doing here is separating. Now let me get my highlighter. And what did I just do? Well, this is the integer portion of 3.5. This is the integer portion of negative 14.2. This is the decimal portion of 3.5. And this is the decimal portion of negative 14.2. Everybody see all that? Now I'm just going to rearrange these by color. 3 and negative 14 are green, they're integers. I'm going to write those together. 3 plus negative 14, and then I'm going to write plus, and now I'm going to do 0.5, and it's going to be plus a negative 0.2. Okay? So 3 plus a negative 14, well, then I take the absolute value of negative 14, and that is 14. I take the absolute value of 3, and that is 3, and I subtract them, and I get 11. The sign of the greater was negative, so this is negative 11. Okay? So I've just done this piece. Then I am going to take the absolute value of 0.5, and that is 0.5. And then I take the absolute value of negative 0.2, and that is 0.2, and I'm going to subtract them. 5 minus 2 is 3. There's the decimal. Here's the 0. The greater number was positive, so this is going to be positive. So it's going to be negative 11 plus 0.3. Okay, so be very careful with this. This is not 11.3. It's not negative 11.3. We then have to, let me change colors, do the absolute value of negative 11, which is 11. We take the absolute value of 0.3, which is 0.3, and we're going to subtract them. So I need a decimal place for my tenths. This 1 is going to become 0, and this is going to become 10. Minus 3 is 7, and 10 minus 0 is 10. So my answer is 10.7, and you take the sign of the greater with absolute value, which was negative, so my answer is negative 10.7. Okay, here's another one. Practice makes perfect. So try to do this on your own if you're watching this for the first time. Pause the video, see if you can do it with this procedure, which is also here. Try to do it using this procedure, and then come back and see how you did. So here I go. I'm assuming you paused this, and we're going to do it right now. Check your answers. So I have negative 12 and 3/4. Split up the integer from the rational. Negative 12 plus negative 3/4 plus negative 5 plus negative 1/2. Okay, just split everything up. Then I'm going to highlight. Okay, this is an integer. This is an integer. This is a rational number. This is a rational number. I'm now going to combine them and rearrange them so they're together. Negative 12 plus a negative 5 plus negative 3/4. I should have parentheses around this as well because of the double sign, plus negative 1/2. Okay? So we'll focus on the integer first. So you take the absolute value of negative 12, which is 12. Take the absolute value of negative 5, which is 5. Subtract and get 7. And since they're both negative, it's negative 7. Oh, I'm sorry. That's not true. The signs are the same. We add. My fault. Okay. 12 plus 5 is 17. So when the signs are the same, you add them because we are adding, right? It says addition. My fault. So 12 plus 5 is 17, and the signs are negative, so that's going to be a negative 17. Okay? We're going to do the same with 3/4 and half, but something has to happen first. Take the negative 3/4 absolute value, which is 3/4. Take the absolute value of negative 1/2, and that is 1/2. But I cannot subtract these, or add them, I mean. Okay, we're adding. I can't add them because my denominators are different. So I'm going to leave 3/4 as 3/4, but I need this to be 4. So 2 times 2 is 4, 2 times 1 is 2. So 1/2 is the same as 2/4. So you add these, and now I'm going to get a denominator of 4, and 3 plus 2 is 5. Well, that equals 1 and 1/4. And since both were negative, that is also a negative number. So now I have negative 17 plus a negative 1 plus a negative 1/4. So I had to break that up again because 1 1/4 is a mixed number. I have to get the integer by itself. And then when I combine these, absolute value of 17 is 17. Absolute value of negative 1 is 1. 17 plus 1 is 18, and they're both negative, so it's negative 18. And 1/4 is also negative because it was -1 1/4, so that's negative. So my answer is just simply -18 1/4. Okay. Finally, we do the exit ticket. So again, pause the video, see if you can do this, and then check your answers. Okay. Okay, you unpaused. Okay, here we go. I'm going to split this integer, -2, plus the decimal, 0.75, but that is also negative. Whoops. Plus a negative 0.75 plus 8. I don't need parentheses. It's positive. Oh. Okay. -2 plus -0.75 plus 8 plus 0.25. Careful, this is plus or positive. So these are all plus. Okay. Highlight your integers. Highlight your rationals. Okay. Rearrange it so they're together. -2 plus 8 plus -0.75 plus 0.25. So we're adding -2 to 8. I'm still going to do the process with the absolute value. Absolute value of -2 is 2. Okay, let me just move this down and put the bigger absolute value on top because we're subtracting. And then I'm going to do the absolute value of 8, which is 8. Okay. We're going to subtract them because the signs are different. 8 minus 2 is 6. You take the sign of the bigger, which is just simply 6. So -2 plus 8 is the same as 8 minus 2. Okay. And then we're going to combine these. So I'm going to do this over here. The absolute value of -0.75 is 0.75. This should be a negative here. The absolute value of 0.25, okay, these are absolute value brackets, not ones. The absolute value of 0.25 is 0.25, okay? We're going to subtract because their signs are different. One's negative, one's positive. We subtract. 5 minus 5 is 0. 7 minus 2 is 5. And 0 minus 0 is 0. Take the sign of the greater, which is negative. So this is going to be 6 minus 0.5. Okay, I don't need this 0. Okay, so 6 minus 0.5, they're both positive, so we can just subtract, and the answer is 5.5. Okay, that's the end of session 3. Thanks for watching, and have a great day. Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 2, Lesson 8, Session 4, and we will be doing the same standards that are here. I'm not going to read through them again. It's the same as Session 1, 2, and 3. First example, I found an error in the book, so I just want to point this out. What they're doing is they're taking these decimal values and separating the ones from the tenths, okay, or the integer from the rational portion. So as you can see, 4.3 is here, 4 plus 0.3 is here. -9.3 is here, -9.03 is here. However, they failed to separate 3.5, which should be 3 plus 0.5. Okay? Like so. So that should be here, that should be here, and that should be here. And that changes the rearrangements of these, but I just wanted to point that out in the book. So at this point here, I'm gonna just eliminate these 2 rows and start fresh. Excuse me. So I'm gonna just get rid of this equal sign and move it over here. And I'm gonna put 3 plus 0.5 plus this, okay? The next step would be to arrange the integers. So we have 3, we have 4, and we have -9. All right, actually, I'm not even going to have room to write that there. And these are all separate. Of course they are. Let me try to grab them and slide them over. So I'm just going to move these down here. So it's 3 plus 4 plus -9 plus, oops, I forgot to go back to my pen, plus, and now we're doing the decimals. 0.5 plus 0.3 plus -0.3. Okay, at that point, I want to point out to you that 0.3 plus a -0.3 is a 0 pair, which means they equal 0. So we can just ignore them. So I'm going to combine these. So it's 7 plus -9 plus 0.5. That's what we're left with. I'm going to focus on the integers now. So, and how do we do that? We take the absolute value of the bigger number, which is 9, take the absolute value of the smaller 7, which is 7, and when the signs are different, you subtract and you get 2. You take the sign of the larger, so it's negative. So this is going to become -2 plus 0.5. I then will take the absolute value of -2, which is 2. I'll take the absolute value of 0.5, which is 0.5, and I'm going to subtract because they're opposites. So this 2 will become 1 because this is 2.0, and I need to make that a 10. 10 minus 5 is 5. Here's my decimal. 1 minus 0 is 1. Take the sign of the bigger, it's -1.5. Okay, and that's the answer to this problem. Okay, next problem. So we're just going to continue doing the same process. So I'm going to get my highlighter out. And 1 is the integer, -3 is the integer, 4/5 is the fraction or the rational portion. So is that one. So I'm going to rearrange them and split them up. So I'm going to say 1 plus 4/5 plus -3 plus a -4/10. I'm then going to highlight them like I did before. This is an integer, and this is an integer, and this is a rational number, and this is a rational number. Rewriting them as 1 plus -3, okay, the yellow ones first, and then put the green ones together. Okay. Excuse me. 1 plus -3. -3 is a larger absolute value. That is 3. The absolute value of 1 is 1. We subtract and get 2, and we take the sign of the bigger absolute. So this is going to become -2. These have to be common denominators. So I can reduce this. So I'm just going to do that now. 4/10, instead of making it 4/10, I'm going to reduce it down to 2/5. So the denominators are equal, so I can add them. So it's going to be plus 4/5 plus a -2/5. And so I take the absolute value of 4/5, which is 4/5. Okay. Take the absolute value of -2/5, which is 2/5, and we subtract them. 4 minus 2 is 2/5, and we take the sign of the bigger, which is positive. So we're going to end up with -2 plus 2/5. Okay, and one last time, the absolute value of -2 is 2. The absolute value of 2/5 is 2/5. The signs are different, so we subtract. And here I need to make an adjustment. Okay. I need to move. Let me just erase it and move it over. I'm going to move 2/5 over a little bit so it's not under the 2. I want it over here. Because we can't subtract a fraction from a whole number, I need to actually make this 2 a 1. And this is 5/5. So I borrowed 5/5, which is 1, from the 2. So 2 now becomes 1 and 5/5, which is still 2. And now I can subtract the fractions. 5/5 minus 2/5 is 3/5. And 1 minus 0 is 1. Take the sign of the bigger. So that is negative 1 and 3/5. Okay. Next question says, in the first round of a trivia contest, Omar's teams earned negative 60 points. In the second round, the team earned 80 points. How many points does the team have after the second round? So our expression is going to be negative 60 plus 80. Okay, we take the absolute value of the bigger number, which is 80. We take the absolute value of negative 60, which is 60. Since the signs are different, we subtract and get 20. Down below it says Carter chose A as the correct answer. How might he have gotten that answer? Okay, so the answer to that would be, it looks like, well, 60 and 80, 60 plus 80 is 140. Okay, but he didn't choose D. So since 60 was negative, I'm assuming that he was assuming 80 was negative as well. So that's how he got A. Number 4. Nadia says that 13 plus a negative 36 is the opposite of 13 plus 36. So let me move that down. 13 plus 36. Well, the opposite of 13 is negative 13, so that's incorrect. Okay. And the opposite of plus 36 is plus a negative 36. Well, that's all right. However, Nadia is not correct because she did not take the opposite of both. She only took the opposite of 36. So actually, the opposite of 13 plus negative 36 is negative 36 plus 36. And I even made a mistake writing this. Okay. Actually, I didn't. This is the opposite. This is what Nadia said. So her only mistake was not taking the opposite of 13. Number 5. All right, here's where we're starting to get into word problems and converting them to sentences. So I'm going to go through this slowly. The sum, I'm going to stop right there. That is an answer when we're adding. So we put a plus sign over the word sum. This is our number, and the word and is our placeholder. And tells us where to put that plus sign. A number. Okay, so let me write this as mathematical equation or expression before I continue. The sum of 6.7, so I write 6.7, and that's where the plus sign goes. Remember I said sum is addition. The word and tells us where to put the plus sign. So 6 plus 7 and a number. I'm going to use a variable x. The word is means equals, and I want a negative number. And I will just say negative y because I don't know if it's the same as x or not. Okay. So it says, what is a possible value for that number? Explain. So I want this to be negative. So if I took 6.7 plus 0, I would get 6.7. not negative. If I took 6.7 plus a negative 6, I get 0.7, still not negative. If I take 6.7 plus negative 6.7, that's going to equal 0 because they're a 0 pair. So now we're down to 0. I want to go into the negative. So my answer is going to be x has to be less than negative 6.7. Because if I said 6.7 plus, and my negative number is now going to be a negative 6.8, my answer is going to be a negative 0.1. And if I did it with the absolute values like we've been, it would be 6.8. The absolute value of 6.7 is 6.7. We subtract and we get 0.1 and take the sign of the bigger, and it is negative. So my answer is x would have to be less than negative 6.7. Number 6. Tell whether each sum is positive or negative, okay? On questions like this, please don't get lazy. You need to show all work. So over here, I'm going to write A. And 36, if I ignore the signs, 36 is more than 24. So I'm going to write the absolute value of 36 first, which is 36. The absolute value of negative 24 is 24. When we have opposite signs, we subtract. 6 minus 4 is 2. 3 minus 2 is 1. Take the sign of the bigger. It is a positive 12. And we answer the question. Okay. Part B. We have 4.2. We have negative 4.25. We have a fraction. We have a decimal. I want to make this a fraction. Either make this a fraction or make that a decimal. I'll turn this into a decimal. So that should be negative 4.25. So I'm going to take the absolute value of negative 4.25, and that is 4.25. Take the absolute value of 4.2, and that is 4.20. Okay, signs are different. We subtract. 5 minus 0 is 5. 2 minus 0 is 2. Decimal place, 4 minus 4 is 0. Take the sign of the bigger, which is negative. And my answer is negative 0.05. So it's negative. Okay. The next problem, you look at this, I see 371 plus a negative 371. Okay. That is called a 0 pair, which means that they add up to 0. Well, 0 plus a negative is always going to be negative. Okay. D. I'm going to use a number line for this one, and I'll explain it using that number line. So if I have this number line, and I mark this as being 0, and then I draw another number line that is this length, and I give it a value of negative 0.4, that'd be the 1, 2, 3, negative 0.4. These are tenths, negative 0.1, negative 0.2, negative 0.3, and negative 0.4. That's the length of this. Then if I draw another arrow from here that goes out just a short distance, and it's a length of negative 0.04, 4/100ths, negative 0.5 is here. So 1/10 of that would be right here. It'd be even shorter. It'd be very short. It would be like almost not a line. Okay, I'll just do it like this. I can't get it much shorter than that. Okay, and I'll just move it like so. So the actual answer, it doesn't matter the length of it, but we are at the point of negative 4.4 or negative 0.44, which is right here. So what I'm getting at is if you go left of 0, which is what a negative tells us to do, and you go left even further, it is impossible to be over here. So the answer has to be negative. Number 7. What is the sum of these? So again, we have an integer and an integer, a fraction, a decimal. First thing I'm going to do is separate these. -1 plus 3 over 10, which is also negative. So don't forget that. So it's -1 plus -3/10 plus -3 plus -0.8. Okay. I'll focus on the fraction and decimal in a minute, but before I do that, here is, actually I'm going to use the same colors just so we know. Okay. This is an integer. So is this. What do I use? Blue. This is a rational number. So is this. Okay. So we're going to rearrange this so they're next to each other. So -1. The other yellow is -3. Then this one, -3/10 plus, and I'm going to convert this to a fraction. If I say this without using the word point, that's how I try to tell students to say it a different way. This is -0.8. But if I'm reading it mathematically, it is also -8/10 because it's in the 10th position. Okay. So this is -8/10. All right. Now I'm going to combine these two. Absolute value, -3 is 3. The absolute value of -1 is 1. Signs are the same. We add, we get 4. Take the sign of the two numbers and we get -4. Okay. Take the absolute value of -8/10, and that is 8/10. Take the absolute value of -3/10, which is 3/10. Signs are the same, so we add, and we get 11/10, and keep the sign negative. So this is going to become -4 minus 11/10. I'm going to rewrite this because that's improper. -4 minus 1, or plus a -1, actually. Let me write it like that. So it's going to be -4 plus -1 plus -1/10. Okay, 11/10 is 1 and 1/10. And then I combine my like terms. And yes, this is tedious, but if they keep doing this over and over, the chance of making a mistake hopefully is less. The signs are the same. We add, I get 5. Signs are both negative, so it's -5 and 1/10. And that's the answer. Okay. All right. Northern gannets are large seabirds that can both fly and dive. To hunt fish, flocks of thousands of gannets descend quickly upon the ocean. So here's a gannet question. Okay, they gave us the background of what it is. So a gannet flies 24.5 feet above sea level. So that's going to be 24.5 positive. It increases its elevation by 5 feet. Then it dives. That's going to be plus a negative, 47.2 feet. After it dives, what's the gannet's elevation relative to sea level? Okay, so sea level will be 0, underwater's negative, in the air will be positive. Okay, so I'm going to do the same thing that we've been doing over and over. 24 is an integer, 5 is an integer, -47 is an integer. 1/2 and 2/3 are rational. Put the integers together, 24 plus 5 plus a -47 plus, now I do my rationals, 1/2 plus, careful, -2/3. Okay, because of this sign right here, the whole thing's negative. Okay, so 24 plus 5 is obviously 29, plus -47 plus 1/2. So I just did one step there, plus -2/3. Now I'm going to take the absolute value of the bigger, which is 47. The absolute value of negative 47 is 47. The absolute value of 29 is 29. Subtract and get 18. Sign of the bigger, it's negative 18. Now I do the same with my fraction. 2/3 is more than a half when you do absolute value. Think of it as 2/3 is further from 0 than 1/2 is. So the absolute value of negative 2/3 is 2/3, right? Distance from 0. And the absolute value of a half is 1/2. I cannot subtract these. Actually, I want the signs are different, so I'm going to subtract, but I can't because the denominators are different. So I need to find common denominators of 3 and 2, which is 6. To get 2 to become 6, I had to multiply by 3. 1 times 3 is 3. 1/2 is 3/6. 3 times 2 is 6. 2 times 2 is 4. 2/3 is equivalent to 4/6, and I subtract. 4 minus 3 is 1 over 6. Take the sign of the bigger, it is negative. Okay, so this is going to be plus a negative 1/6. So when they're both negative, they just go back together. The answer is negative 18 and 1/6, and that's feet below sea level. Okay, that's pretty impressive. Think about that. This bird was 24 feet in the air. It dove down to the oceans, hit the surface of the water, went underwater 18 and 1/6 feet, which is 18 feet 2 inches. That's pretty amazing. Number 9. Okay, they're giving us a bubble chart. This is a type of question you might see on a PSAT or SAT, and this is the answer process. So that's why they're applying it to this type of format. So all it is asking us what these two numbers sum are. So you take the absolute value of the larger number, okay, and that is 1,037. You take the absolute value of the smaller number, or the one that's closer to 0, if you will, and that is 582, and you subtract. 7 minus 2 is 5. 10 will become 9 when I borrow. 13 minus 8 is 5. 9 minus 5 is 4. Take the sign of the bigger. It is negative. See the negative sign there? Negative. Okay, and it's going to be decimal point. No, there's no decimals. It is going to be negative 455. So I'd put bubble the 4, bubble the 5, and bubble the 5. Okay. Closing exit ticket. I'm not going to do this because it's an explanation. I'll leave that to the students. Thanks for watching and have a great day.